Welcome to our podcast, Bridging Connections. Hi, I'm Abul Islam, founder and CEO of AI Engineers. Many of us in the architecture, engineering, and construction industry are watching with interest the trends, conversations, and disruptions which can dramatically integrate and improve our industry. Everything from artificial intelligence to innovative project delivery methods is dominating the conversations about infrastructure, design, construction, and maintenance. We'll be talking to thought leaders, pioneers, and listening to the important voices and opinions in these exciting discussions. Our first topic today is the use of new technology, specifically the use of artificial intelligence in bridge inspection and evaluation. Our guest is Kevin Hussain, one of our own. Kevin is our Director of Engineering. He's a senior member of our technology group. Kevin has many years of experience as an engineer, inspector, team leader, project manager on large and complex bridge inspection projects, and routinely, regularly, may I say, deals with bridge management staff at a number of DOTs and truly understands the sensitive nature of bridge inspection, which is a 24/7 job for some of the urbanized bridges that we are providing inspection and evaluation support to our DOT clients. Kevin also has an interest in new technology, AI, artificial intelligence in particular, and is also a very proactive member of his community as a citizen. We will hear a lot from Kevin today. Kevin, welcome, and I'll give you the floor now.
Thank you very much, Abul. In some sort of way, we are pioneers because this is our first podcast. So thank you for having me. And give you a quick background again. I initially started my career over 15 years ago with a large inspection or large engineering firm, and I've done a lot of work over the last 15 years, from states all the way down south to Georgia, all the way up to New Hampshire, and then sprinkle a little bit of my work in different other states. But the majority of the work recently has been in the tri-state area, specifically New York, Connecticut. And the transition, what I want to talk about is the transition of engineers ourselves, is that from that we, I've done design work, I've done load rating work, I've done inspection work. So I've been in the trenches, been on construction inspection sites. And in my work that I do now, I try to leverage what I've learned so far into how we need to look as engineers. You know, we're always looking at things black and white, right? We wanted to be things done in a way that it was either given to us, do it this way, or here's what I want and here's what you're supposed to get. And we, unfortunately, because of the new technologies and other factors, which we'll get into later, we have to start thinking outside the box. And it's important, though, to know that you have to align yourself with, a good group, a good boss, and a good team, but also a good company. And in addition to that, a good client. Because if you have all of these ingredients, it'll make for a great and efficient workforce.
Before I get into the actual topic, I just like to say that a lot of studies are coming up with regard to that what are the fundamental forces that is going to shape our life, not just the United States but the whole world, will impact in the structural forces. One is population, shift of population, migration of population. The second is the climate change, and the third is the impact of new technology, and of course the fourth is economy. How the economy, shift of economy, the GDP growth or not growth in a certain area, the movement of goods and resources. This is going to dominate the next 20 years, and reshape. Climate change being one of the fundamental ones. Of course, there are, when you talk about economy and population, there is also the equity problem, that while if there's a growth, economic growth on existing models, that it also creates a disequilibrium, if you will, in terms of the opportunities for more poorer people in a society, whereas there's the glaring inequality between the opportunities. So all of these are fundamental structural forces, although it doesn't have directly any work that we do as engineers in our profession, but we have to be mindful of that, and we have to really speak talk about, imagine what new technology can do, because that's something that we practice every day or in our work, to alleviate and improve some of the conditions and improve the lives of people, livelihood, and economic disparities, and the challenge with climate change, with the intensity of storm becoming more frequent, more damaging, rebuilding after the storm, the tremendous amount of resources and monies are required, and then the lessons learned after the storm as to what not to do with regard to our infrastructure. Move our, for example, the storm Sandy in 2012 taught us that the best way to put the basement, the boiler room, HVAC room, is not at the ground level, but move it up. But that cost a lot of money. Just to give you an example, to move up your HVAC and system from ground floor basement to the second and third floor. So all of them are intertwined together. Electric vehicle is coming up. There are like 50 companies whose stocks are going up and down, and right now because they're being commercialized. All of this coming at a very fast rate. And I wonder, is that our governments, state and federal and municipal, are fully capable to address the changes that are happening so fast. Any insight on that with regard to that before we go to our main topic of artificial intelligence and bridges, Kevin?
Well, honestly, you mentioned something there, and you talk about equality and equity. And honestly, in our transportation infrastructure built environment, there needs to be that too. And I think what the new technologies are doing now, there's a lot of hidden correlations that this new artificial intelligence and the new technologies that we're using will be able to use those hidden correlations to provide a more diverse and a more inclusive network for especially inner cities that are not being serviced, and on public transportation, where our bus system goes, where our high-speed train goes, where our high rail, our light rail goes, even our off ramps and exit ramps were usually put into large inner cities, and then those areas gets basically sectioned off, and then you see a lot of high crime, a lot of violence. So believe it or not, what new technology is going to help us do is help with those hidden correlations. Once we have the data, it's going to help us provide more diversity and inclusions. On a lot of national organizations outside of work, and we're writing white papers to present to our politicians how the transportation, as I said, is a bloodline, but also how it affects societies and communities, and why we need to address certain parts of it, and why we need the funding most of all to support this type of initiative. Our number one goal as an engineer, as a designer, as a load rater, as an inspector is, across the AEC industry, is that public safety is our number one goal. And as much as we try to be more effective, efficient, quality, safety is our key. And believe it or not, the AI, artificial intelligence, is part of safety. Is what we're trying to do, is to accelerate how we do things. If we want to improve, do it better, do it faster, do it cheaper. That's always been our goal, but without affecting the safety part of it, the component of it. Specifically, I'll talk about some bridges, but what I'm going to say in general about AI, artificial intelligence, is that it applies to the entire sector, the entire AEC sector, architectural, engineering, construction sector. So when I say things, I want to make sure it encompasses that. And at least the first ingredient, those I mentioned earlier, is having a firm, like I said, that not just throws out the word AI for marketing purposes. Being in an agile firm, and again, I'll name drop here a little bit, being an AI engineers, we're a very agile firm. And it starts with your team, like I mentioned earlier. Once you have a team that can collaborate, that's the most important part, because then there's no sort of friction internally of who's saying, well, he's going to take away my work, or he's going to take away my work, or the machine is going to... No, it's not that. It's a collaboration. You're still going to need the human component. That's one of the challenges, that the opportunities that people don't realize. I went to a conference at RIDOT a few years ago, and they were putting in these electric vehicles. See, all the bus drivers and unions were going, oh my God, we're going to be out of work. These are driverless buses, right? That's going to be implemented in 4 or 5 years. And there was a big discussion about that. But what they didn't realize is that there'll still be operators. They'll still be maintaining it. They'll still be, they'll still be training. The workforce will be shifted into something else. They won't be losing their job. It's the same thing with like electric vehicles with artificial intelligence. No one will be potentially losing their jobs. It's just a shift in how we do things. We'll still do it, but we'll just do it, cheaper and faster. Coming back specifically now to the AI part of it, the best way to deal with a problem, usually the way we do things now is to fix it, right? Something gets broken, we're very reactive. We're never proactive. So what we're saying, the best way to deal with a problem is to prevent it. Why wait until it's broken? Let's prevent it, and that's where AI comes in. We're going to be more proactive, and we're going to use this predictive analysis to basically use a predictive analytics for preventative maintenance. And again, it comes back to being in an agile firm. What it does when you have an agile firm or an agile group, it gives us the opportunity to explore the unexplorable, right? Generally, as I said, engineers want to do things this way or this way. But when you think outside that box, when I was talking about that shift, you as engineers, you have to start thinking of different ways of doing things. And not only that, stepping out of your comfort zone. I've climbed many bridges and I've done a lot of design work and load rating work too, but trying to fly a drone for the first time was pretty scary. But you have to come out of your comfort zone to do things, right? You want to test the waters, right? Someone said it's always better to ask for forgiveness than to ask for permission. So sometimes, safely, I should say that, right? So it's okay to step out your comfort zone to do stuff like this. So basically that's what we've done here at AI Engineers, and we've worked with a few of our regional clients on some proof of concepts where what we're using is that there's a linkage between the condition state of a bridge and the performance and funding. So generally, historically, we've used historical data to allocate future expenditure. What we're saying, what if we use future data to allocate future funding? We can use this proof of concept of this predictive analysis for preventative maintenance simply by predicting what this bridge is going to react 5 years from now, 10 years from now. So what we're basically saying is that we're going to take all the data, the big data that our clients have, our DOT has, our municipalities have, and we're going to put it into our AI machine. Let's call it IBM Watson. And what we're doing basically, for the new technologies such as drones, 3D lasers, scanners, we're talking about all the new technologies. We're putting all of it into one basket, and we're producing these large quantity of data, and we're going to analyze it, and we're basically going to say, listen, we're going to take this data and do some proof of concepts and predict what's going to happen in a short term, long term, a medium term, and a long term. And then use that data and present it to our clients to say, instead of fixing 10 bridges today, and we only have this amount of money, based on our AI prediction, we don't need to fix these 10 bridges now. Let's fix these 2 now. These other 5 are going to be in a 3 to 5 year period, and now this other 2 is going to be in another 7 to 10 year period. So what it does, it gives you the money to focus on the stuff that's really bad, and therefore saving the money to work on other things that's needed for our transportation sector. Sorry, it's a long answer.
No, this is good. This is the role that we would expect, that the inherent subjectivity that is there for human data collection versus artificial intelligence, and to make that jump over there too. So one thing is that there's a subjectivity in collected data. There's no question about that. The conventional inspection has longer time span with regard to the total inspection time, number of hours of labor consumed, whether it's a 3-person team, 2-person team, access equipment guys, bucket truck or snooper staying there for 8 hours and only 2 hours of productive work in Cross Bronx Expressway and all that because of the traffic. There's over 100,000 ADT, so it reduces your production time and you lose it. So the question is how this transition can impact the existing order of inspection, existing way of doing, and how we can convince the state DOTs, even if we have a successful model, to embrace it, such that the dollar that I mentioned for $2 to $4 billion, even 10% of that, $400,000, or 20% of that can be saved as a first step in the next couple of years. If a certain state DOT who owns the largest number of bridges embraces that one,
I want to repeat this again. I know it's a collaborative effort between new technology and the human aspect of it. And I want to mention this too, that it's the expert this decision making is still necessary. We can never remove the expert decision making. We can never remove the hands-on inspection for fracture critical bridges or fatigue prone details. And for those of you, there's still going to be the human component. It's not going to be, it cannot be alleviated. It's federally mandated that we have to have our hands on some of our built environment. We have to put our hands on there. So what the new technologies would help to do is, for example, like you've mentioned, we have large large roadways that carry heavy volumes that just becomes a disruption to traffic, and that becomes a safety item because people get distracted, people get killed during work zones. I mean, even most recently in not our project, another vendor's project, they had an employee who was seriously hurt because someone was just texting and didn't see the lane closures and just hit someone. So what we're trying to do is that basically you said we're using the new technologies and we're going to try to come up with ideas that will feed the data, and they'll say, listen, instead of spending 15 days with access equipment that costs $10,000 a day, you only need 2 days of that. So if you do 15 times 2, that's almost a saving of, we're talking about 70% of your costs on direct labor or direct costs again. So the machine learning, the algorithms, and even just the inspector who says we can use these new technologies in a toolbox, use a drone and fly for areas that doesn't require an underbridge access equipment. We can save 5 days of that with just one drone flight. So it introduces, again, comes back to safety. There's so many safety components to it, but it also reduces costs. Because now instead of spending 10 days with lane closures, access equipment that costs $15,000 a day, we may only use 1 or 2 days where the inspector comes and put their hands on as federally mandated on that equipment. So basically, you could reduce 80% of that time, but you then take that 80% that you've saved and put it onto something else. It's not a cost saving necessarily for the program, it's a cost saving for that bridge. It still stays in the program, but now we can spend that money in something that needs more attention. So instead of now spending 2 days on a bridge that had, serious conditions, we can now spend 15 days, I'm saying, to document those conditions so we can present it to our load raters and designers and said, how can we fix this now instead of it being really bad, 5 years from now, So there's tremendous amounts of cost savings and safety, the safety part of it too. I just want to circle back on what you mentioned about, let's start back and give a little bit of summary on the built environment. The transportation system is the lifeblood of our economy. It's that simple. If we, even in the current pandemic, essential workers, not only our medical field, but our construction workers, our pavers, and all our bridge inspectors were deemed essential workers. In like the medical field, the transportation system is the lifeblood of our economy. So it is a key component of what we're doing in today's life. I want to talk a little bit about your also about the paradigm shift. So I talk about a paradigm shift, especially in engineering, because we are transitioning initially from the way we've done things, where people knew new technologies were going to come. Case in point, we are all in the new administration, and even before that, we were trending towards a carbon emission-free technology. 10, 15 years from now, we're going to see less, vehicles that utilize gas on the roadway. Give and take Tesla and all the new electric cars. So the paradigm shift again is right off the bat. Where's the funding going to come from? Our local and state and national leaders are having a hard time figuring out how to pay for our infrastructure system. We've looked at tolls. We've looked at increasing the gas tax, which will be dissolved in 10, 15 years. We're even looking now at a VMT now, which is potentially a vehicle mileage tax. So like you've mentioned, you're only touching about 5 or 10% of what's needed, and then the long term now is that they won't even have the money to fix that. So that introduces now another challenge. How do we pay to fix something if the money is not there? So I think that's where the new technology comes in, and we'll touch some more on these topics. But I just wanted to recap how the new technology and the paradigm shift now is that we knew it was coming, but what the pandemic has done is it accelerated everything. It's brought to light that everything that we forecasted is now here at a real faster pace. So we're forced now as engineers to address these challenges now, think outside the box. We look at our aging and infrastructure. They were built to be resilient, but like steel, it has a lifeline. So we have to pay closer attention because that lifeline was 20 years ago. So we're basically putting bandages on our built infrastructure. So that's why we have to look at innovative ways and innovative technologies, and to address all the aging infrastructure, we have to look at non-standard approaches. We have to look at the 4 or 5 ingredients, which includes time and cost. And like I mentioned, there was a big climate change, and not necessarily the climate of actually the actual climate itself is getting bad too. And because we've seen a lot more larger storms, higher frequency storms, it's overburdening our transportation system, our storm pipes, our highways, our roadways. The storms in the winter are getting greater, and it's more stress on our steel bridges and our concrete bridges. So it introduces a lot more maintenance. So I think that's where a transition in now, that we need to look at the new technology for preventative maintenance. We need to predict that. We'll get into some of that some more into the podcast, but I just wanted to throw that out there. The last thing I want to say is that we have to use what this new technology introduces. It introduces these challenges as new opportunities for us to address these as not as challenges, but opportunities to fix them. I'll speak specifically today about the artificial intelligence, which is what we're focusing on the new technologies. We're leveraging this new technology specifically because of the pandemic, because what it's done, it's made us pivot, because what we wanted to do 5 or 10 years from now, it's forcing us to do it now because of the pandemic and the low ridership and the low turnaround when all the investments or your day-to-day activities, there's no funding out there anymore. Agencies are struggling, the government is struggling, so we have to now pivot, like I've mentioned, and accelerate the use of new technologies, and specifically, I'll focus on artificial intelligence. What artificial intelligence is going to help us in our industry, specifically the AEC industry, and I'll keep it down, I'll pin it down to the bridge inspection and evaluation part, is that it'll help us with the automated extraction of these large data and put it against the traditional scientific method. So now everything is more automated and everything is extracted using these algorithms and machine learning and all the big data, whereas we grew up with the scientific method. You have something you want to work towards, and this is what you do. We're going to use all this high-end data now. The other part of it is that these data sets are already easily accessible because the DOTs have them, our clients have them, our agencies have them. So it's not something that we would need to go fishing or spend more time on. It's already there. This needs to be tapped in. Those resources are all there. And one of the other things that this artificial intelligence is going to do, is going to help us with the hidden correlations. We talked about equity and equality. We talked about diversity and inclusion. A lot of our low-income cities and our our socioeconomic gaps that we have could be addressed, believe it or not, in our transportation sector by deep data recognition that artificial intelligence would be able to correlate to us that we never saw that was there. And one of the other things too is the automated decision making. Like I mentioned, there is still going to be a human decision making concept, but the automated decision making is going to be very key, because we can put into 5 or 10 different parameters, and based on the historical data, it will tell us here's what your most likely scenario should be based on cost, time, or safety. So for example, we wanted to build a bridge, a 5-span bridge over the Connecticut River. It will tell us, we plug all the data in here, and it will tell us, here's what you should present to the DOT as your most viable option that will work given all the parameters. Last but not least, specifically, now I'll get into the bridge inspection side and evaluation, what we do here at AI Engineers. We generally wait for a problem to provide a solution. So what we're saying is that don't wait for that problem to provide a solution, prevent that problem from happening. And that's where we're going to leverage and use artificial intelligence for predictive analysis for preventative maintenance. And all we're going to be doing specifically is that we're going to be using more, instead of the reactive form of doing business, we're going to look at things more proactively. And part of the solution is that we're going to use this predictive failure with machine learning. We're going to forecast and predict the downtime for critical infrastructure assets. We're going to use these same assets and put them into statistical algorithms, or SA as most people may call them. And we're going to use the machine learning and deep learning to help extract those capabilities. Some of the other things we're going to do, and what it's going to do, it's going to help us improve our inspection method with all these new innovative technologies. We're going to become more adaptive and more a connected company. And when I say connected company, not only the AI engineers specifically, but with our clients. We're going to be able to tell them and identify more cost-effective solutions. We're going to help them with their asset management, maintenance, and more importantly, safety, which is what is our number one goal. And like I mentioned before, the hidden correlations are going to uncover underlying issues that they may have that they may not know that they have, such as drilling down into the health of the assets, or even shortening inspection cycles like we spoke about. Instead of spending more time, we'll put in threshold and indicators and trends that will help them in their analysis. The other thing I want to touch about quickly is that artificial intelligence is just going to help us improve our inspections in total. It's going to improve accuracy and objectivity in our industry, not only in the inspection industry, but architectural engineering and the construction industry. The goal is also with artificial intelligence, we're going to have a centralized database now. If we can help our clients have a centralized database, not only for AI engineers, but for all their clients, we can help them with a centralized database so they can have all their consultants and all their data working off one centralized database. We can design an entire bridge without printing out a paper copy because we can do everything through BIM, and digital twins and so forth. And then that's going to help with a continuous improvement of how we do business, which in turn is going to help us with costs, and which is what we're talking about. And a couple more things is the linkable application of artificial intelligence to other asset managements, and that's key. Like I said, right now we have multiple agencies within an agency that don't speak to each other. Departments don't communicate. Once we have those linkable assets, it becomes this ginormous brain that everyone operates more efficiently, what to do, when to do it, and so forth, instead of acting independently. And predictive asset management is very key also. The artificial intelligence part is going to potentially track changes in defects and in numbers and in condition states, which in turn is going to help us with the predictive asset management. You need to fix these guide rails, or you need to fix this part of a roadway, or you need to manage this pavement before this storm comes, or before this winter season comes. And lastly, we can come back to the modeling, 3D modeling using LiDAR, combining all the technologies now with the AI to make it one whole compatible modeling for bridges and other asset managements and other features. So in turn, artificial intelligence is, like I said, is going to be leveraged in ways that, in our minds will not be able to accept it. But the major key here is that it's because of the pandemic, we're forced now to stay ahead of the curve. AI engineers and other engineering firms, including agencies, are having to accelerate the way that they're doing things as it comes to technology, and artificial intelligence is only going to help accelerate that even more.
One question, Kevin, with regard to a little bit of what an inspector experiences every day. That's part of his job, is to document the deterioration of the structures, i.e., the cracks, concrete structures, or steel structures. A big part of the effort is documenting and then coming to a judgment where the crack is and how it is impacting the overall structure, or not to be very concerned, depending on inspectors do the whole structure where it is. Now, how can techniques using artificial intelligence, how can that really reduce and make the inspector's life a lot better for data collection and for the owner to access that data instantly or at a whim?
Basically, what we're looking at is that a combination of the data will be used for this evaluation. So, for example, high resolution cameras will be taken, in the field to grab photos. Drone images will be used. LiDAR. What we'll do, we'll combine all that data, and what it does, because they're all geotagged, they all have a process that goes into the back end of it, and it ties everything together. The machine learning or the algorithms are going to be able to say, here's what I see right now, a size of a crack, the length of a crack. It'll be able to detect corrosion in steel structures. It'll be able to determine what's rusted, what paint has been removed. What we're not doing yet is that it won't be able to give us depth yet. That's another part we're working on. Eventually, we maybe can use thermal imaging to give us depth, but it'll give us enough information that we need to rate the bridge on the national level, or the federal highway level, which is put it into a conditioned state. So, for example, if we have an entirely new bridge, we can send out a drone, grab all these photos, put it into the artificial intelligence program, and it'll tell us, you need to go spend 1 day to put your hands onto these items, because here's what the items that we think you should look at. Traditionally, what we'll do, we'll go with a brand new bridge, we're going to go spend 6, 7, 8 days, and we're going to spend all this money for access equipment and all this time. Whereas the machine learning will tell us, or the algorithm will tell us, you don't need all of that. Save that money for something else. Take this time to go look at what we found from these cracks or this corrosion and the section loss and so forth.
Fantastic. That is the tremendous capability that this technology has. I'm so excited.
I must follow up with it. We do have a few proof of concepts with other agencies in the tri-state area. I'll be as vague as I can, but they are very signature bridges
Yeah,
that
I know.
we're looking at. And what one of the proof of concept we're working on is exactly that. We flew a drone flight, we grabbed the data. Now they're going to put those data. They're going to separate the cracks. They're going to separate all the section loss, the rust, and so forth. And it's going to try to put it into different condition states and come up with a predictive rating for that bridge or for that section of the bridge that we did. We're going to use that now and present it back to the client and show that proof of concept. And then we've also working on some other crack mapping on some other larger concrete structures where we've used this high quality digital imaging and from drones and from high quality Canon cameras. And the algorithms have already map cracked the entire structure. So the inspectors no longer have to go there and spend days looking at every single crack. They can spend one day, just use a drone, use a camera, and just put it into the program, and it says here's where the propagation has been, and they can document the propagation. Think about, I personally have been into large segmental box girders. Quality of air is bad. You need a third person. You have air meters. You don't want to spend 4 weeks in a segmental box girder map cracking. It's just painstaking, and the safety issues too. So if we can get one inspector go in and take photos, or one drone, one of our mini drones, and fly it and get that data, it reduces the amount of time, and safety and cost. So.
Yeah. So the tricky part is that everybody knows AR, VR, but then there's MR, mixed reality. That was a lot of research has done in a couple of universities last few years, where there is this happy balance between the virtual inspector and the human inspector, on the two extremes of that. So if that happens, what you're describing is somewhat similar to what the concept was in various papers that were written in the last couple of years at the universities with the inspector and the artificial intelligence, the machine are collaborating to at an optimum point where there's a lot more efficiency and reliability with the data that you get, the quality of the data.
Yeah, we as you know, obviously, we are working with local clients, but we're also working, like you said, with a lot of universities and a lot of international consultants. We actually have a consultant we're working with right now with artificial intelligence in the Netherlands. But the idea, though, coming back to your point of the mixed reality or the collaboration, we've tried the Microsoft HoloLens, where we potentially could put a HoloLens with an inspector in the field and bring him out there and collaborate with a client with using the mixed reality. We've looked and explored it. Looking at pipes in a mechanical room, and a client might be in another country, and we'd want to explain to detect conflicts, or maybe with the architecture, or maybe with the designer. We're looking at all these technologies, and that's the other thing with clash detection. We have programs that do that right now. All of that will only be heightened and would only be more scrutinized using artificial intelligence.
So, Kevin, here is an important item to discuss, and I want your take on this one. The implementation of artificial intelligence in the domain of bridge inspection and evaluation for us. What are the challenges, for convincing or persuading our clients, to adopt some of the state-of-the-art technology that we already got here and is working? What are the roadblocks? What are the challenges? What are the impediments in implementing this thing at our client level, with the DOTs or large municipal agencies that we serve them? What do you think that what the challenges are for them to embrace these new technologies faster, if not universally in the next couple of years, and how we can think of solutions about that one, if any?
That's a good question. It's a two-part question, because the artificial intelligence itself has its challenges. Like I mentioned before, it's expert decision is still necessary. So it's still going to need a human, decision-making process as part of it, even though most of it is automated. So again, some of the additional artificial intelligence challenges will also be, what we find is that it requires true data. Luckily for us, DOTs have this true data. So we'll be able to get that data, our inspection reports, condition survey reports, we have the data. So our data, generally, it's true data is hard to get, but because of the historical data from all DOTs and other agencies, we have that. So it's a challenge that becomes an opportunity for us, like I mentioned earlier. There's some other costs that are associated to artificial intelligence with the data entry, data processing. It's a cost still that's would be accounted for in the overall process, but it is still a data entry type of cost, analyzing that data. I think one of the other challenges that we may have is finding the suitable learning model or optimization model or algorithm that suits that need. So there'll still be some flushing out of the suitable model, the algorithm for what that need is and optimizing that. That's the challenges on the artificial intelligence side. On the agency side, what we found that, like, for both local, state, and even government agencies, there are more conservative owners, bridge owners, or built environment owners, and there are more proactive ones, or ones that are more receptive. And we live on the East Coast, but I hate to say this, but we see a lot more receptive to new technologies in the West Coast. California, Utah, some of those areas are way ahead of the East Coast, and we usually see that in a lot of our trending. Our in housing, everything happens from the left to the right. Left coast to the right coast. So that's some of the challenges that we have. That some of the DOTs are going to have to be more receptive and open. And I look at a word of trust. That I think they need to trust consultants. That we're not just here for the money or the grab or the work, which is part of it. We have to sustain our bottom lines, but trust us that we are a representation of you. We are we're your stepchild, but we don't look at it as a not caring for you as a department. We want to have you to trust us to do the same work that your staff would do, but we will do it for you same way. And I mentioned earlier about that paradigm shift. One of the challenges DOTs and municipalities are going to find, just like the bridges that were built 20, 30, 40 years ago, the workforce was also deteriorating. There's not enough positions being filled at DOTs. There's not a lot of money available for due to the large packages that that each one of these jobs carry. So there's also a shift where the workforce has been completely drained. People are retiring, and there's no one replacing that. So they're going to have to trust the consultants that we can do the same work for them. And honestly, and it's shown on national statistics that we can do it cheaper than when an additional agency or a DOT representative or employee does it. So those are some of the challenges I think that artificial intelligence and new technologies will address, but also it's an opportunity for us to take advantage of.
So well, I think I will also speak to that, Kevin, that 38 years in this industry, and I joined, 38 years ago with all these bridges and highways, so many design, inspection, evaluation, and when I joined the industry, we looked up to the state, and the federal government for guiding us with regard to anything from fracture critical guidelines to drainage manual to structural design, AASHTO, how AASHTO's contribution and the entire spectrum of our horizontal highway and bridges going back to 70, 80 years, So we looked up to them for guidance when we came to a stopping point in our thing, that is there a publication out there? And there was usually a publication or a guidance or a seminar, this is how to do it and all that thing. Now, I find this thing completely lacking, now in 2021, and that when it comes to new technology, I don't have the same approach with the DOTs. And part of the reason is, as you explained, that attrition. A lot of very experienced people in the craft of engineering, bridge, highway, whatever, has retired or about to retire, and they have not filled their ranks that they used to. Hiring hordes of people right off, state universities and all that, into every year. That's not also happening. So there is an organizational issue with regard to accepting change, and big change, disruptive. That how, I don't have an answer that why a decision cannot be made by a second or a third tier, hierarchical, staff that they run. They don't run. They're big entities, usually state DOTs, and they have to run in a hierarchical sort of bureaucratic way. I understand that. I get that. But even in the older times, they used to work in that same bureaucratic way, that used to things get done. Built all these fantastic highways. But why it is taking, much time and sometimes indecision in embracing something that makes a lot of sense, because the decision-making process is not as it used to be. That's my take on that.
Yeah, absolutely.
Kevin, I like to thank you for taking your time from your busy work schedule and kind of illuminate us and our audience with regard to the topic, new technology, and particularly artificial intelligence use in bridge engineering. I hope that only with time that our main clients, the state DOTs, see the value and virtue of implementing it with their inspection staff. Nobody's proposing dramatically changing, altering the inspection staff and the judgment that the inspector's judgment, the engineer's judgment that we have developed over the years. But embracing artificial intelligence and new technology is the way to go for the good of our community and our society. So I again thank you very much for joining us today in my first podcast, and thanks for your time.
No, thank you, Abul. I appreciate it. And I just want to reiterate that, not only in our industry, our day-to-day lives, new technology is part of our living now, from our smartphones to going to the grocery stores and see the robotic machines around checking for, fruits and if they're fresh, to, driverless cars, as you mentioned earlier, Tesla. But the other important part too, is that our workforce, our generational workforce of having a lot of younger engineers who are driven by technology, or basically who grew up in technology, and not only that, the passion that they want to see a more efficient, cleaner world, more diverse, equity. I think the new technology, ties into the concept of us having a cleaner life, a better life, and a better world to live in. And I think eventually engineers, old and new, and our clients, mostly our DOTs and our agencies, will transition into the same concept of being more receptive to new technologies and putting it towards good use. So thank you very much.
Thank you for joining us in Bridging Connections today. I hope you enjoyed our conversations. Please feel free to like, comment, and subscribe below. Once again, this is Abul Islam, and I look forward to seeing you soon.